Consider this. Everything you see, everything you touch, even you yourself are the result of chemistry. It's true. At the very heart of chemistry are things called chemical reactions. These are the processes that make everything happen. A chemical reaction is like a cosmic dance where tiny particles called atoms rearrange themselves. They break their old bonds and form new ones. It's not magic, it's science. This constant shuffling of atoms is what builds our world from the ground up, from the smallest grain of sand to the biggest, brightest star in the sky. It is the fundamental way that matter changes from one thing into another. Think of it like playing with building blocks. Imagine you have a house built from red blocks, a car built from blue blocks. A chemical reaction is what happens when you decide to take both structures apart. You then use those same red and blue blocks to build something completely new, like a spaceship or a castle. The blocks are the same, but what you've built is totally different. That's exactly what happens with atoms. You don't need a fancy laboratory with bubbling beakers and strange glowing liquids to see chemical reactions in action. Your own home is a fantastic chemistry lab. Think about what happens when you bake a cake. You start with a gooey mixture of flour, sugar, eggs, butter. These are your reactants. After you put it in the hot oven, something amazing happens. You pull out a fluffy golden brown cake that smells delicious. The cake is your product. It's a completely different substance from what you started with. All thanks to the heat from the oven causing a series of chemical reactions. Let's consider another example, one that you might not think of as chemistry. Have you ever left a bicycle out in the rain? Over time you might notice reddish-brown patches forming on the metal parts. That's rust. Rusting is a chemical reaction between the iron in the metal, the oxygen in the air, and the water from the rain. The iron atoms combine with oxygen atoms to form a brand new substance called iron oxide, which we call rust. It's a slow reaction, but it's a powerful example of how substances can change their properties, becoming weaker and more brittle over time. It's chemistry in slow motion. So what's really going on during a chemical reaction? Why do substances change? It all comes down to atoms and the connections between them, called chemical bonds. Think of atoms as tiny social particles that like to hold hands. These hand-holding connections are the bonds. In a reaction, atoms let go of current partners, then grab new ones. This grand rearrangement, the atomic switcheroo, is the essence of a chemical reaction. Atoms don't change identity, a carbon stays carbon, but their arrangements do. First, old bonds holding reactants must be broken. That usually needs a bit of energy, like the heat from a stove or the spark from a match. That initial boost is called activation energy. It's a nudge that gets atoms moving and shaking to break old connections. Once bonds break, atoms move and find new partners. They form new, more stable bonds, the products. When new bonds form, energy is often released.